Hello everyone, my name is Matteo and I am the developer of an implementation of the IPAdapter for ComfyUI. IPAdapter is basically an image prompter. It takes an image as an input. It is encoded and converted into tokens that then are mixed together with your standard text prompt to generate a new image. There are actually two extensions for the IPAdapter on ComfyUI. One is mine and it is called ComfyUI IPAdapter Plus, and the other one is called IPAdapter ComfyUI. I believe that mine has a couple of benefits. The first one is that it follows closely the way ComfyUI does things, so it is more efficient and it shouldn't break if ComfyUI gets updated. It also introduces a couple of important features. One is the noise that should grant arguably a better result, and the other one that I just implemented is the option to import and export pre-encoded images. So let's start from the beginning. This is a very basic workflow. All the magic happens in these nodes. So first of all, we need to load the IPAdapter model. There are many available for SD15 and for SDXL. We'll talk about all of them later. And then we need the clip vision encoder. There are two of them. One, it is called SD15 and one SDXL. It is not as straightforward as it may seem because the SD15, it is sometimes used for SDXL models, and we'll talk about that too. So I loaded the SD15 image encoder and the IPAdapter SD15, which is the simplest of the models. I then loaded an image reference and linked everything to the apply IPAdapter node. The weight, of course, is the strength. We'll leave it at 1. We do not have any text prompt, so we can use a very strong weight for this image. I am just adding blurry in the negative because that really helps. So by default, the key sampler is at CFG 8 and steps 20. And let's see how it goes. So with just one image reference and with no text at all, we are already able to achieve a pretty decent result. But as you can see, the image looks a little burned. The IPAdapter models tend to burn the image a little, and we can solve that by lowering the CFG scale. And we also need a few more steps just to give the model more time to generate the image. So let's try again. And this is already better. So let's see what we can do to improve this already very decent image. We talked about the noise option. This is an exploitation of the IPAdapter model. Basically, by default, the IPAdapter sends two images. One is the reference image and the other one is a black image. What I'm doing is sending a very noisy image instead of a black one, and the noise option is basically the amount of noise that I am going to send. So let's try with 0.33 and let's see the result. And it is very pretty. Of course, we can improve even more with some text. As we are using a text prompt, we also want to lower the weight of the image itself, so the text has a higher relevance, and we can try again. And this is already a very decent result with just few words, one in the negative and one reference image. To reach the same result with just text, it would take a lot of prompt engineering. We can try to add something in the negative. I like to add horror. Sometimes it helps. We can generate some more images just to see how it goes, and you will see that they are all very nice, and it's very hard to find a bad picture. Okay, now we are going to try other models. The most interesting is probably the IPAdapter SD 1.5 Plus. The difference is essentially the number of tokens that these models are going to create for the image. The base one is only 4 tokens per image, and the Plus is 16, so a lot more. And let's see how it goes. And we are going to go back to 1 and remove noise, and let's try with a vanilla configuration, and let's see how it goes. So the image, maybe it is not as good as before, but it is certainly closer to the reference image. That is, of course, important. We can try to improve again the image by adding some noise. Let's see. And put the text back with a lower weight for the reference image. And again, we reach a very decent result that this time is a little bit closer to the reference. Let's try another one. So now let's talk about how to prepare the reference images for the image generation. So far we've used this image, which is a square, so it's very easy for the models to work with this, but it may happen to have like a portrait image, for example, like this one. Let me show you what happens if I send this image without any preparation. Let me remove the text, set back to 1, and yes, also remove noise. As you can see, the image is not centered. This is because the clip encoder resizes and crops the image to the center. Any image that is in portrait on landscape mode, it is cropped to a square in the middle. In this case, the center of attention is of course the face of the girl, so we need to prepare the image better for the encoding. For the purpose, I have a node called prep image for clip vision, and instead of sending the image directly to the IPAdapter, I'm sending this to the prep node, and as you can see, the crop position is on the top. We can select the better position for the crop. We have other options, but at the moment we don't need them, and we send the image to the IPAdapter and generate again. As you can see, the girl is not cropped anymore and is nice into the frame. Next, we want to send more than one image to the IPAdapter. So I'm loading a new one. Let's do this one. Okay. To do that, I'm using the batch image node. We can simply merge the two images together like so and send them both to the IPAdapter, generate again, and I will have a nice merge of these two images. Of course, I can add more. And let's see what I've got here. I need another batch image node. I can put this one, the previous batch here, and then everything to the IP adapter. Generate again. And now the generated image gets all the features from 3 pictures. These 2 images are already a square, so they don't technically need to be prepped for the encoding, but we can try anyway, because sometimes, for example, using a better interpolation algorithm, you can get better results. Let's try. And now the face is a little bit more detailed, which is nice. We can do the same to the other image. I take another prepare node. It's usually a good idea to prepare the images before sending them to the IP adapter, but your mileage might vary, so it's always better to experiment. There's one last thing I want to show you, that is the option to sharpen the prepped images. So I can, by just adding a little bit of sharpening to all 3 of the images, sometimes you can get nicer results. Let's see. It's a lot more defined. You can see there's a black line in this jewel and whatnot. It's up to you. It's an option that you have. A quick note about selecting and using multiple images for your generation. Say I want to create Street Fighter characters of famous actors. So I picked a series of 6 actual Street Fighter characters, and I put Rosario Dawson as Street Fighter character, a few negatives, and let's see how it goes. So this is pretty good already, and I'm happy with the result, but what happens if I remove 4 of the images? I mean, the image is of course different, but it is not that it's worse. The main elements are all there, and I reached more or less the same result with just 2 images instead of 6. This is because my reference images, despite being all different from one another, they all reiterate on the same concept. They are all video games, they are all female characters, they are all fighters, so it is worthless to add more of the same element. So you are not trying to train a LoRa. You are adding tokens to a composition. So when you are adding a new image, ask yourself, what is this image going to add? Does it really add new elements? If it doesn't, you don't need to add that picture. Should we try with just 1 picture? As you can see, we lost some elements on the hair, but overall the composition is still good. So since adding new pictures is actually expensive, let's try to not overdo it. Let me try to add actually something new, like some icebergs. Now I have some real change, so the settings now is on ice at least. Okay, let's move on to the next topic. Another very interesting model, it is called IPAdapter plus face. It is a model specifically trained for describing faces. It is not a LoRa, it is not a face swap. It just tries to describe as close as possible a face that you give it to it. For example, the ethnicity, the eyebrows shape, the expression, the hair color, and so on. So being just for the face, we need to give a context to our scene. Something like this, a superhero woman wearing a high-tech costume, cinematic hero pose, dramatic lighting, close-up. We of course need to lower the weight to give the text more relevance, and let's see what we get. So as you can see, we have our superhero with a face that is very close to what we gave as reference. So let's talk about SDXL now. You need, of course, the IPAdapter SDXL model, the SDXL image encoder, and of course the checkpoint of your preference. Let's see how it goes. The SDXL base model, in my opinion, is not great, but again, with the noise option, you can get some nice result. You can see it's a lot better, but fortunately we have other models that we can use. One of them is the IPAdapter plus SDXL VITH. So it is important to remember that all VITH models actually need the SD15 encoder, even if they are for SDXL checkpoint. So I select the SD15 encoder, but the SDXL VITH model. Let's see how it performs. The composition is very close to the original. The image itself is not great, but we haven't given any prompt. You can try with noise, and now it's very pleasant and also very close to the original. There are other models you can experiment with. Just remember that the VIT-H models require the SD15 encoder, even if they are for SDXL. And the other interesting one is the SD15 Lite. You can use this when the text prompt is much more important than the image reference. Otherwise, it is identical to the base SD15. Now let's see how to add more conditioning to our image using image-to-image, Inpainting, and ControlNet. Image-to-image is straightforward. Let's say I already generated this image over here, but I want it to be in the style of this reference. So all I have to do is to encode the image from the pixel space to the latent space and feed it to the K-sampler. I set a denoise of 0.35, so the important features of my original image should stay the same, but still receive quite a bit of conditioning from the reference. So let's see how it goes. And look how pretty she is. So of course, as always, we can improve our composition by maybe adding some text. If I add some text, I have to lower slightly the weight. Let's see. Already better. And as always, it's worth a try to add some noise, as it generally grants prettier results. And with very little effort, we added the style of the Venus of Botticelli to our astronaut. What if I want to change only the face instead of the whole image? That can be done with Inpainting. I need the Inpainting encoder. We connect the image. Okay, then I create a mask. We can roughly select the face, connect to the key sampler, and set the denoise back to 1. And for better results, I need to select a checkpoint for Inpainting. Of course, we need to select the mask and go. So the reference image remains more or less the same, but the face has been updated with the IPAdapter model. The best way to interact with IPAdapter is probably through ControlNets. Let's say I want a portrait of a woman with this style, but the head position should be like this. There are many ControlNets that I can use. The easiest one is probably Canny. It's an extremely fast preprocessor, and it's relatively light on the image generation. I connect the Canny preprocessor to the Apply ControlNet node, reducing the strength a little to give the model a little leeway. I also lowered the weight of the IPAdapter for the same reason, and we can try and check the result. So as you can see, we have the general look and feel of the reference image that we sent to the IPAdapter and the head position of the ControlNet image. The result is already very nice, but as always we can add some noise, and look at that. Just as a reminder, the noise option is something exclusive for my ComfyUI extension for the IPAdapter. Is something that not even the IPAdapter developer thought was possible, and it's a kind of exploitation of the system, but it works really well, so I decided to make it public anyway. We've already talked about image to image, and of course the same concept can be used for upscaling. IPAdapter is so good at describing an image that it is very effective when upscaling with pretty high denoise. In this case, I'm using a 0.5 denoise for upscaling and a very simple upscale. I'm not using a model, and I'm going to generate two images. The first one is using IPAdapter, and the second is without. Let's see how it goes. As you can see, the woman upscaled without IPAdapter is basically another person compared to the reference image, while the girl upscaled with IPAdapter keeps most of the original features. Also, if you look at the patches on the spacesuit, on this image is basically completely made up, while on the IPAdapter it kept something of the original. Of course, we can lower a little the noise for a result closer to the original image, but we are going to lose a little bit of sharpness. Of course, if we had to use model upscaling, the result would be even better, and this can be useful especially for SDXL, since we do not have yet a tile ControlNet. One last thing before I wrap up. Let's say I have a set of 4 images that I like as reference for the IPAdapter. I am also pre-processing them. I am cropping to the top this one because it is in portrait mode. I am adding a little bit of sharpening to this one because it is a little bit blurry, and I really like the result, and I now want to create like 100 pictures with this reference. It is a little wasteful to encode these images every time that I need this workflow. The images are actually encoded only once, and then we hope that the 4 GB encoder is unloaded. But what we can do is to pre-encode our reference with the IPAdapter encoder. Instead of sending the images directly to the IPAdapter node, we send them to the encoder together with the Clip Vision encoder. And what we need at this point is a new IPAdapter that takes already encoded images. So now we can connect the embeds to the embeds, the IPAdapter model to the IPAdapter, and then the checkpoint. We don't need this node anymore, and we can remove it. So if I generate the image again, the result will be the same. it is important to note that the noise also has to be set. Okay. The cool thing is that I can take these embeds and save them with the IPAdapter save embeds. Now they are saved on disk. You can find them under the embeds subdirectory in the output directory of your ComfyUI installation. And we need to copy this file into the input directory. At this point, we don't need any of these nodes, and of course we don't need the image encoder. All we need is the IPAdapter load embeds, and here you will find, we probably need to refresh, and here we find all our saved embeds. We select the file that we moved into the input directory and we connect to the embeds. Generate again, and the result is exactly the same. So at this point, your images are pre-encoded and you can reuse them without wasting any resource. From my test, this configuration saved me about 1.5 gigabytes of VRAM. And of course, you can send this file to your friends or post it on Civit AI and have others create the same kind of images with your embeds. So this pretty much covers the basics of my extension for ComfyUI and the IPAdapter. Be sure to download the ComfyUI IPAdapter Plus extension, and remember that this is not a model that needs training, so it is worthless to send 100 reference images to the IPAdapter, because it is only going to waste resources. You really have to cherry pick your reference images, and the less the better. There's actually a training script on the IPAdapter repository that can be very helpful if you have very specific needs, and it is also very simple to use. So if you already have experience training, for example, LoRa's, this is something that you can try. Maybe we can do another tutorial about that specifically. That's all for now, and see you next time. Ciao.